Hello, welcome back to Pre-Calc. This is a video over section 2, which is the changes in period and phase shift of sine and cosine functions. So our objectives today, we want to relate transformations of the graphs of the sine and cosine functions to the equation. Okay, so the first thing we want to talk about is period and frequency. Now we've already talked about period, but we want to talk about a little bit more of a formal definition. So the period is the horizontal length of one cycle of a periodic function. So when we just have a typical sine function, so I'm going to write in here, this is the sine function, y equals sine of x. My period for this is going to be a length of 2 pi, okay? And remember, again, period is just the one cycle of this function before it starts to repeat. So what I can do is I can come in here and I can say, all right, we start here at 0, and we do this wave function, okay, going up and down and back. And right here is where we have one period, okay? At that point, okay, we can have another period, all right? And that period goes from 2 pi to 4 pi, and we get the exact same thing, okay? So we can come in here and we can say, well, our period is 2 pi, okay, we already know that. And one way we can kind of figure that out is by saying, okay, we go from 0 to 2 pi, okay? The next thing we could say is that we go from 2 pi to 4 pi, okay? And the distance between 0 and 2 pi is 2 pi, and the distance between 2 pi and 4 pi is also 2 pi, and that's how we get our period, all right? So that's pretty standard, pretty easy, I think, for a standard sine graph, okay? But we have this thing in here with this multiplier, okay? So we have this b value. So y equals sine of bx, okay? And this value for b affects the period, okay? Okay, and what that will do is that will change the frequency at which this occurs, okay? Um, so the b value affects the period, and let's take a look at just an example here to talk about the frequency, okay? So the frequency is the number of cycles of a periodic function that occur in one horizontal unit. Now remember that our normal period for a sine function, so even though we're dealing with sine of 3x here, okay, when we think about the period of y equals sine of x was 2 pi, okay, and that's standard for any sine function. But what I want you to see here is that all of a sudden, here's 2 pi, okay, we have one cycle, we have two cycles, and we have three cycles, okay? So all of a sudden, when we introduced y equals sine of 3x, okay, and when we compare it to y equals sine of x, this contained three cycles. So what this does, so we had, and let's write this down, that we had three cycles within 2 pi, okay? And so all of a sudden, our period changes, okay, with this graph, all right? And so let's write down a couple of formulas, okay? And I would put this maybe over on the left side. So we have a formula to talk about our period, and we also have a formula to talk about our frequency, okay? So the formula for our period is going to be 2 pi divided by b. And then our frequency is actually what we call the reciprocal of that, and we're going to say that this is b over 2 pi. Okay, so if we're talking about y equals sine of 3x, okay, our formula for period to show what the period value is, okay, to identify the period here, what this is we're going to take 2 pi over 3, okay, because our b value is 3, and that's our new period for this graph, okay? And so this value here would be 2 pi over 3, okay? This value here, we'd add another 2 pi over 3. This would give us 4 pi over 3. And then this would give us 6 pi over 3, which is 2 pi over 3, okay? So now...
Can it just be 2 pi?
Yes, that would just be 2 pi. And so, you know, what you have to think about here, okay, is the difference between what this says, okay, between our period that we have, which I think we're okay with, but then identifying what this frequency thing means. The frequency thing says, and I set it down here, okay, 3 cycles within 2 pi. So they for period and frequency, they mean the same thing. It just depends on what you're saying. So when I put in the 3 here into this formula, okay, that means I have 3 cycles per 2 pi, per length of 2 pi on the graph. Now, another thing that is happening in this scenario is, let's think about what's happening to the unit circle. Okay. What does x, let's think about what x represents in the unit circle. Okay, if I do y equals sine of x, remember x represents your angle measure. And if I'm doing sine of 3x and I'm affecting the angle measure, what I'm doing is I'm essentially, if you look here between 0 and 2 pi, we had 1 cycle. We go around the circle once. If we've got y equals sine of 3x, we are going around the circle 3 times. And that's what's happening when we are affecting the input, when we are affecting the x value and multiplying it by a number. Okay? And that's what's going on. Okay? All right, now let's talk about horizontal translation and phase shifts. So a phase shift is a fancy word for a horizontal translation of a periodic function. And all that means is, you know, horizontal translation, so phase shifts. Now remember, with horizontal translations, we go opposite from what the sign tells us. Okay, so opposite from what the sign tells us. Okay, so if you remember, okay, if we add or subtract something for the input on the inside of the parentheses, okay, and in this graph, look what we've got. We've just got, you know, y equals cosine x. So here's our cosine graph, okay? And all we're going to do is we're going to shift this graph pi over 2 units. So shift pi over 2 units to the right. Okay? And the reason I know it's to the right is because the right is the opposite from a negative sign. Okay? If you're thinking negative, typically you would go to the left, but because we're shifting it, horizontal shifts always go in the opposite direction. So, you know, let's think about what's happening here. Okay? And so if I go from this point to this point, okay, all we're doing is we are adding pi over 2. All right, to go from this point to this point, we are adding pi over 2. All right, and so on and so forth. Now, here's the cool thing. All right. What kind of graph is created here? If you think about this graph here, it's your sine graph. And let's just think about, what happens in the unit circle, okay? If you were to sit here and say, okay, we're going to start this, instead of starting it at 0, okay, we would start it at pi over 2. And so it shifts everything on this graph 90 degrees, and that's how we get those values. Kind of crazy. So yes, you're right. Y equals cosine of x minus pi over 2 is the same thing as y equals sine of x. Okay. All right. Let's put this all together here. Okay. And so we've learned various things. Okay. We have learned about the amplitude of our graph. We have learned about the period of our graph. We've learned about the horizontal phase shift and then the vertical shift. So what we want to do is come over here and graph this equation, okay? And so let's do this. Let's identify what all these values are, okay? First things first, we're going to look at the amplitude. Now the amplitude is our multiplier here. Our amplitude is going to be a value of 3, okay? Now, because we are negative here, we are going to reflect this across the x-axis, okay? We have cosine of 2, so 2 is our b, okay, and that's going to affect our period. So what I'm going to do is I'm going to do 2 pi divided by b, which is 2. So we're going to do 2 pi over 2, which is just going to give us pi. So our period is going to be pi, okay? Horizontal phase shift means that we are subtracting 60 degrees. So we are going to shift right 60 degrees, okay? And then vertical shift, we're going to move this up 1, okay? So let's do this. Let's draw out, and I'm going to label out from 0 to 2 pi, so 360 degrees, 1 and 1. At 180, we have negative 1. And then at 90 is halfway between 60 and 120, and then 270 is between 240 and 360, okay? So we have our normal sine graph, and it's important that we graph that as well. What are we at, 180? Okay, and then 720. So we're going to do two of these here, okay? And then let's connect these with a curve. Okay, so we've got two of those, okay? So now, all right, which one should we manipulate first? What do you think? Should we affect the amplitude? Should we affect the period, the horizontal shift, or the vertical shift?
Vertical.
You want to do vertical shift?
Yeah.
So here's the issue. Okay, yeah, let's do that. All right, so let's do the vertical shift. All right, so let's move everything up 1 unit. I think that's a good idea. Okay, so we've got those points on the graph. Okay, so it doesn't necessarily matter what we do now, but I think that was think that was a wonderful idea. Okay. Now, let's do. All right, so we want to reflect this across the x-axis. Let's do that next. Okay, switch over to green. So let's reflect these points across the x-axis here. Okay. And then let's affect the, let's do the amplitude, okay, of 3. So remember what I'm about to do here. Let's think about our horizontal at this point is at -1. These values aren't going to change. The values that are going to change are your maximum and minimum values. Okay, so these values are going to go up 3. So let's do this in yellow, make this go up to 3, and this will go down to 5. Okay, this point's going to stay the same. This point's going to stay the same. This point is going to go down to 5. Okay, this one's going to go up to 3. This one's going to stay the same. This one's going to stay the same. And then this point is going to go down to 5. Okay. All right, so now what that does, and remember, that makes the radius of our graph much bigger. Okay. Okay, now the next thing I want to do is we want to shrink up all these values and have a period of pi. Okay. And so let's change my color here, change to brown. Okay. And what I want to do is think about the points where everything repeats. Okay. And I'm going to shrink those up and move them down by a half. Okay. And I'm going to move this guy over 180. I'm going to move it over to 90. Move this guy over. Okay, yeah, so this is where it gets tricky. All right, so let's do this. We want to have another one, so 270. Sorry, I'm just kind of thinking out loud. Okay, so there's our graph. Okay. Okay, and then the next one, we want to shift everything to the left 60 degrees. Okay. So this point over here, let's go with, I'll do the final one in black. Okay, I'm going to shift everything over 60 degrees. All right, so everything we want to move over. So this point here, how many boxes is that? 4 boxes. 1, 2, 3, 4. Shift it over to here. Shift this over 4 boxes. 1, 2, 3, 4. 2, 3, 4. And you want to connect your points like so. So you do have a lot of things going on here, but the black graph that you see here is the graph of this function. Okay, so there are ways of doing this. Desmos is your friend on this, but we can do it by hand. Okay, so wanted you to see how to do it by hand, and hopefully that made sense. And we'll go from there. So see you later. Bye.